Students, we have a question. In the given congruent triangles under ASA, find the value of x and y. So let me draw the triangles. So we got two triangles. Okay, all right. So we've been given two triangles, say A, B, C, and you got 60 degree, say 5 centimeters, and 30 degrees, and P, Q, R, you got 60 degree, and you have 5 centimeter, and we are expected to find the value of x and the value of y. Now it says ASA. Now what exactly ASA stands for? It means angle, side, angle, criterion. Right? Now you got an angle here, and you got a side, you got an angle here. You got an angle being given, you got a side, but x is not given. So what should be the value of x? Now there is a very important rule you can use to ascertain, right? So this is how the solution has to be written. Given that a triangle ABC is congruent to triangle PQR, it's given. Right, the triangles are congruent by CPCTC rule. So what exactly is the expansion for this rule? It means corresponding paths of congruent triangles are congruent. Right, remember this, you have to state this. By this rule, clearly x should be what? This is the corresponding angle, right? X should be equal to 30. Now since we know in a triangle some of its angles should be equal to 180 degrees, so in this case 60 positive 30 positive y should be equal to 180 degrees. So this would mean 90 degree positive y is 180, therefore y is equal to 180 negative 90, and y is equal to 90 degrees. So this should be your solution. So therefore you can state it, x is equal to 30 degrees and y is equal to 90 degrees. So you need to write all of these content to get A plus. So if you are in grade 8 or grade 7 or even grade 9, you are expected to draw the figure, put in this information, because this offers a justification. Outwardly, there is, it doesn't make any big impression, because if 5 students are simply stating x is 30 and y is 90, all 5 of them are not going to be getting the full score. Because there would be some, imagine the 6th student is presenting all this information, right? So he gets an added advantage. So that's why explanation and supporting that explanation with the theorems is indispensable when it comes to solving questions in mathematics. So thank you, students. We move on to the next question. Let's do this question, students. We've been given this question. AP is equal to BQ, RS is equal to QS. Show that APS triangle, APS is congruent to triangle BQR. So foremost, let me give you the figure. This is the way the figure looks. This is one part of the figure, and we got the other part. Which is moving out like that. So you got A, P, R, S, Q, and B. Now we are expected to show that A, P, S is congruent to B, Q, R. And we are given this information. This is 90 and this is 90. And what else we have given? AP is equal to BQ. So this side is equal to this side, right? So now we need to show that this triangle is congruent to this triangle. So that would mean we need to show that one of their sides concur. Now over here we are given RS is equal to QS. This is actually not RS, this is PS, right? We are given PS is equal to QS. So PS, it's actually PR. Okay, so a slight change in the question. This is PR is equal to QS. So this part is equal to this part. So we need to show one of the sides for these triangles, they concur. So they are congruent. Now let me start off. Of course, this is settled, right? This side AP is equal to BQ and you got an angle. Now to use the criteria, angle, I should say side, angle, side, I need to show one of the sides of these triangles, they agree with each other. That is important. Now what we are given that PR, this part is equal to QS, right? Now let me add RS both sides. Adding RS both sides, what do we get? If I were to add RS, so you got PR here, I'm adding this part, RS both sides. I'm not making any change, right? All I'm doing is to add a quantity on the left, quantity on the right. And that is not going to alter the equation. RS and RS can be cancelled. But what is PR plus RS? This is nothing but PS. What is QS plus RS? Right? This is nothing but QR. So I should have, I can rewrite this as QS plus SR. I can always do that, right? So this is nothing but QR. So this is equal to QR. So now what are we trying to show here? We are trying to show you that PS, this side which is part of the triangle APS is equal to QR, which is part of the second triangle, right? If I were to take this as 1, take this as 2, I have clearly shown here PS is equal to QR. This would mean by side, angle, side, by side, angle, side criterion, we conclude that triangle APS SAPS is congruent to triangle BQR. Triangle BQR, right? So that is the end of this particular question. It's a lovely question which allows us to introspect the figure by fragmenting it. So we'll move on to the next question. Students, we have a question in the given figure. Triangle BSC is equal to triangle QRP by SAS criterion. So they are asking us to use side angle side criterion, right? So this is what we need to use, side angle side criterion. So the moment we know this, then it's easy to solve. So this side is corresponding with this side. So from the figure, you have to state this: since the triangle ABC is congruent to triangle PQR by side angle side criterion, this would mean this side 3x positive 10 is equal to 5y positive 15. It doesn't matter what they give in the question. All that matters is this information. Once we have this information from the figure, it's simple to solve. So if I were to rewrite this, this is going to be 3x negative 5y is equal to 15 negative 10. So 3x negative 5y is equal to 5. So this is one equation we have got. Also, again you got to state it by SAS, side angle side. So the angles correspond. So side angle side. So what do you have? You got 2x positive 15 is equal to 5x negative 60. I move this to the other side. So 15 positive 60, I bring this to this side. 5x negative 2x. This would give me 3x. This would give me 60 positive 15. That's 75. I can rewrite this. This means 3x is equal to 75. So x is equal to 75 over 3. 3 divided 7 2 times, carry 1, 15. So that would be 3 times 5, 15, right? So x is equal to 25. So clearly x is equal to 25. This is the value we are getting. You don't have to put degrees and all because x is also being utilized here. So this would mean, right, from 1, what do we get? So this is 3 times of 25 negative 5y is equal to 5. 3 5s are 15, 3 2s are 6, 75 negative 5y is equal to 5. Move this side, move out this. So 75 minus 5 is equal to 5y. So 5y is equal to 70. So y is equal to 70 divided by 5. 5 divides 7 once, you carry 2, it's going to be 4. So therefore y is equal to 14. Now they are asking us to just find the value of x and y. So probably you can rewrite here solution and then x is equal to 25 and y is equal to 14. That's it. You don't have to do anything else because this is the requirement for this question. So that is the end of this particular question, students. We'll move on to the next one. Students, we have a beautiful question. In triangle ABC, medians BD and CE are equal and intersect each other at O. Prove that triangle ABC is an isosceles triangle. So in an isosceles triangle, we have to state this. So let me start the solution like this. In an isosceles triangle, two sides are equal or of equal length. So that's an important point. Okay, let me draw the figure. So and we got two diagonals. Now two diagonals are intersecting, and in fact, instead of saying diagonals, I should use the word medians, right? You got medians BD and CE. So let me draw BD. So let me find out the center. So when we talk about medians, they will bisect or intersect the sides of a triangle exactly at the center. So have that in mind. So I've got a center located here. So I will connect it. Because of the fact it's a median, the intersecting point would be at the center. Okay. Okay, so this is what we have got. Let me name them A, B, C, and this is D, and this is E, and this point is O. Now the proof is complete if we can show that AB is equal to AC. Alright, so that is the objective for this particular question. And let me start off like this. Given that BD and CE to be the medians, this would mean BD will intersect side AC at the center, and CE will intersect the side AB. You can probably use the words exactly at the center, right? So these two sides are split exactly at the center, and similarly these two sides are split exactly at the center, right? Now the next important point has to be taken into account. Since BD and CE are medians, they intersect each other in the ratio of 2:1. This is very important. So clearly you can see this side is bigger than this side, and similarly this side is bigger than this side, right? Given that BD is equal to CE, this is given, right? Where is it given? You see this question, BD and CE are equal. So if I were to take 2/3, multiply both sides by 2/3 of BD, so this would mean 2/3 of BD is equal to 2/3 of CE, right? But what is 2/3 of BD? You see this? This is the larger side, right? So 2/3 of BD is nothing but OD. What is 2/3 of CE? That's nothing but OC, right? So what have I shown here? I've shown OC is equal to 2/3, in this case 2/3 of BD is OB. This should be B here. It's not because this is the largest side, right? I have placed the OD. No, OB. 2/3 of BD is OB. So this should be the larger side. OB is the largest side, and CE, 2/3 of CE is OC. So this is correct, right? So what I've shown here, I've shown OC and OB are same. Fair enough. That's nice. So this is 0.1, right? Now if I take 2/3 away, 2/3 of BD away, then there is 1/3 also. What is 1/3? 1/3 of BD. So this would mean 1/3 of BD will be equal to 1/3 of CE, right? But what is 1/3 of BD? This would mean 1/3 of BD is nothing but OD. So OD will be equal to 1/3 of CE. 1/3 of CE is this small part. That's equal to OE. So this part OD is equal to this part, right? Since next one, since the medians BD and CE intersect each other, the angles present here will be one and the same, right? So you got a side angle side here. That is an important observation. And you got a side angle side. So this would mean opposite angles are equal. So that's the important thing, because you got an opposite angle here, you got an opposite angle here. So since the medians BD and CE intersect each other, this implies opposite angles are equal, right? So because of this fact, opposite angles being equal, I can apply, this means we can apply side angle side criterion to conclude that there is a triangle here. You see that there is a I'm talking about the triangle over here. This is a triangle here, and you got another triangle here. So to conclude, BOE, I'm going to conclude this. BOE is congruent to COD. Now we have now come to a conclusion that this shaded triangle and this shaded triangle, both of them are congruent. Now what does that mean? This means there is a beautiful rule which I have already mentioned to you all in the previous questions, by CP-CTC rule. So what is that rule? Let me write that expansion. This is called as corresponding paths of congruent triangles are congruent. It's a powerful rule. Corresponding paths of congruent triangles are congruent. Now this would mean, what is the meaning of this? This means this one and this one, they have to be congruent, right? This means BE is equal to what? CD, right? By this particular rule. Now multiply this by 2. 2 times BE is equal to 2 times CD. I've already mentioned to you, the medians, they divide the side into 2 equal parts. That's a speciality. That's why we call them as median. So 2 times BE. So 2 times of this is what? 2 times of this is nothing but AB. So this is going to be, this means this is nothing but AB. So 2 times of CD is what? 2 times of CD is nothing but AC. So I've clearly shown AB is equal to AC. So this means the given triangle ABC is an isosceles triangle, and that is the requirement. That's what we need to show. So hence this completes this beautiful question. It's a lovely question. Thank you, students. Enjoy your day. Students, we have a beautiful question. Let me state that question. In the given figure below, PQ is equal to CB, PA is equal to CR, angle P is equal to angle C. The question is the triangle QPR, is it congruent to triangle BCA? This is the question that's been asked. If it is congruent, if your answer is yes, then state the criteria or criterion, right? So this is the question that's been given. Now foremost, let me draw the figure. Right, so that's one part of the figure. You got the other part also. So let me name the figure. So you got P, Q, R, and this is A, B, C, and you got this side being equal to PQ being equal to CB. That's fine. So this is what we got, and angle P is equal to angle C. The question is it or the figure given, are they congruent to each other? That's the question. So we need to show that, or we need to give the proof. Now what are we given? Solution. This is the solution. We are given that PA, this part, let me draw that part, PA, right, is equal to CR. So I'm stating that given that PA is equal to CR. Now let me adding AR both sides, we get, so what do we get? I'm adding AR plus PA is equal to AR plus CR, right? Probably I can rewrite this as PA plus AR and rewrite this as CR plus RA. PA plus AR, this is nothing but PR. CR plus RA, this is nothing but CA, right? Now where is PR? PR is over here. This is PR, right? Now what is this? This is nothing but base of triangle QPR. And what is CA? CA is also, when you flip it, this can be written as, say for example, instead of saying base, because it's on the upper end, I can say this to be equal to side of triangle BCA. So BCA. So instead of saying base, probably I can use the word side, right? Base is also a side of a triangle, right? Now hence we see that instead of saying C, I want to use the word observe. Hence we observe that PQ is equal to CB or BC, right? One side is equal to side, and then angle P is equal to angle C, angle P is equal to angle C, and side PR is equal to side AC. So what is this? This is side, and what is this? Angle, and what is this? Side. So hence by side angle side criterion, we conclude, what can we conclude? We conclude that triangle QPR is congruent to triangle BCA. So that is the solution for this question. It's a lovely question, and we move on to the next one. Let's do this question, students. Given that triangle ABC and triangle PQR are both isosceles with AB being equal to AC, PQ being equal to PR respectively. If also AB is equal to PQ and BC is equal to QR, are the triangles congruent? Which condition or criterion to apply? Right, this is one part. And then if angle B is equal to say 50 degrees, we are expected to find R. So let me draw the figure for this question. Drawing figures are very important, so take some time to draw the figures, right? So even though it's a triangle, make sure you are drawing the triangle. That's important. So let me draw the next one. Okay. So this is A, B, C, P, Q, R. Okay. Now, triangle 1 and triangle 2, both of them are isosceles, right? So AB is equal to AC. So AB is equal to AC. So let me write that down. AB is equal to AC. and PQ is equal to PR. PQ is equal to PR. So both the sides are equal. Now this is an isosceles triangle and we are given angle B is equal to 50 degree. Now if this is 50 degrees, so let me state that given angle B is equal to 50 degrees, since triangle ABC is an isosceles triangle, for sure two angles should be equal, right? So the exact opposite of B would be also equal to 50 degrees. So that is the first thing that we can see. So if this is equal to 50, this will also be equal to 50, right? And we are given that AB is equal to AC. So that's the data from the question. Now the next thing is AB is equal to PQ. Now also given AB is equal to PQ, and over here from the figure or from the question we know that, what do we know? We know that PQ is equal to PR. Now AB is equal to PQ, PQ is equal to PR. So if I were to take this as 1 and take this as 2, from 1 and 2 we get, so what do we get from 1 and 2? We can clearly say AB is equal to PR. So AB and PR, so this side and PR, this side are one and the same. We are expected to find this angle. We don't know what is this angle. I'm coming to that point yet. Now we are given that AB, side AB is equal to PQ, right? And BC is equal to QR. So if you were to take this one BC, this is going to be equal to QR. So this side and this side are same. This side and this side is same. We are also given this side AB is equal to PQ. So we can state that AB is equal to PQ. So I'm going to give a strike here, right? Because all these, this side is same as this side is same as this side. So we got three sides lined up. Now, as I mentioned to you, this side is equal to this side. So two sides are equal. So the angles, this angle and this angle should also correspond. Now the question is, we have to establish their congruency. That's the important part. Now we can utilize another information. AB is equal to AC. So that means this side is also same as this side. So now clearly we can see AB is same as PQ, right? And then AC is same as PR. So in fact, we can also state BC is equal to QR. So by side criterion, this triangle is congruent to this triangle. We observe that, we can state that, we observe that AB, side AB is equal to PQ, that's for the first one, and then AC is equal to PR, second one, and then BC is same as QR from the question itself, QR. So hence by side criterion we can conclude triangle ABC is congruent to triangle PQR. That's fine, right? Now because they are congruent, angle B should be equal to angle Q. Since the triangles are congruent by CP, CTC. What is the abbreviation? Stands for corresponding paths of congruent triangles are congruent, right? So corresponding paths of congruent triangles, these two are congruent. So this is going to be 50 degrees and this is going to be 50 degrees. So this means angle C is equal to angle R. Since angle C is equal to 50 degrees, this would mean angle R is also equal to 50 degrees. So this is the end of the solution. This is a lovely question, students. We'll move on to the next one. Let's do this question, students. Given that triangle ABC is isosceles with AB being equal to AC, also AD is perpendicular to BC, meeting BC at D. The question is, are these two triangles congruent? That's a question. And the triangle that they are talking about is AB, triangle ABD and triangle ACD. This is just for your understanding. I will draw it and show it to you. The next question is, state the criterion that is used to determine their congruency. That's the first, that's a next part, or it's a part of the question. And next part is, which side of triangle ADC equals BD. And finally, which angle in triangle ADC equals angle B. So this is quite a sum, right? So you got multiple questions to be answered. So foremost, let me draw the triangle, right? That's critical. Whenever you're drawing a triangle, you have to make sure that you're getting closest to the perfection, right? So this is A, B, C. Now AD part, first part, of course AB is equal to AC, so it's an isosceles, so this angle will be same as this angle, and AD is perpendicular to BC, so there is a perpendicular being dropped meeting at D. It's all given, so when you draw the picture, everything will fall in place. So you draw it here. Now this is a perpendicular, so this is 90, this will also be 90. Now this side is same as this side. Now the question is, we are asked to show that the triangles are congruent. So let me draw this triangle. So I have a triangle here. This is one part of the triangle, and I got the other part. Let me draw the other part. Okay, this is the next part, and clearly we see this is 90. This is 90, this is 90, this is A, B, D, This is ADC. The figures are not to scale. This is same as this. It's given. What is given? Given AB is equal to AC. So you have a 90 degree here. And then they share a common height. So this height is same as this height. Now what criterion can we use? Clearly this is 90 degrees. So we can use the RHS. By RHS. So what RHS stands for? RHS stands for right angle, hypotenuse, side criterion. By this criterion we can clearly see or observe that triangle, we are looking for ABD, right? This is what we are looking for. Triangle ABD is congruent to AC, triangle ACD. That's fine. First question is answered. We have also represented it. So this is done. Now, which side of ADC equals BD? Which side of ADC equals BD? Now, naturally, it's going to be DC, right? Now, why do I say DC? Because by CT property, right? Let me state that property. By CTC. So what does it mean? Corresponding paths of congruent triangles are congruent. Right? So what is the corresponding path for BD? It's going to be DC. So these two are one and the same. So the question is asking you, state the criteria that's completed, determine their congruency, and then which side of ADC equals BD. So this is going to be the side. So clearly the side of triangle ADC that equals BD is side DC. So you got to state that, right? You can say either say DC or CD depending on what you want. So you can state here BD is equal to DC, right? So that's the second part. Now which angle of ADC equals angle B? Now you have angle B over here. So which angle do you think should be? As I mentioned to you, by the same property, the corresponding parts of congruent triangles correspond. So the corresponding part for this is this part, angle C. So for that, you can clearly state angle B will be equal to angle C. Or if you want, you can state it like this: angle ABD is equal to angle ACD. Either like this or like this, it's fine. So this completes our study on congruent triangles. Students, enjoy your day.